Isolation versus isolating. What's the difference? When you're talking transformers, there's a huge difference between an isolation transformer and one that is just isolating. I'm going to try to explain the differences here, and I'll show you guys with the meter some test results to prove the difference between the two different setups. I only have one here, but I can simulate the other. Let's check it out. Hey guys, I thought I had this covered before. I thought I did a very in-depth explanation of an isolation transformer and how it works and why you need one and how they work to protect you and protect your test equipment. I thought that the last video I did was fairly self-explanatory, but I keep getting comments from people that don't seem to understand the difference between the different types of so-called isolation transformers. So I've got a drawing here to try to explain this, and we'll try to demonstrate it with a meter as well. Now, as you know, your AC power coming in from your outlet, you've got a hot and a neutral and a ground. And the neutral and ground are actually connected together at the utility pole as well as at your electrical entrance. So I could put a connection here between the neutral and the ground because they are effectively connected together at the pole, at the transformer, and again at the house. They are not separate. They are bonded together. I didn't draw it on here, but now I just did, just for reference. On the many types of isolation transformers that have been sold on eBay, for example, they're not a true isolation transformer. They are in the sense that they're isolating, and they're this type, by the way. They are in the sense that they're isolating your equipment from the line coming in, the hot coming in from the street. These are typically what are referred to as medical isolation transformers or equipment isolation transformers. The principle behind them is you've got your nice AC waveform coming through, which is being coupled through the magnetic core of the transformer, but any high frequency noise, any RF or any transients that's getting in here, any garbage that's getting in here higher than the resonant frequency of the transformer is not going to make it. So you could have your sine wave with a bunch of garbage on here, and what's going to come out here is a nice clean sine wave instead of a sine wave with all kinds of garbage on it. That's what these do. They do not protect you in any way, which shape or form whatsoever, because they still have a hot and a neutral. Because one side is referenced to ground, which is connected to the neutral. So in this case, I drew that in just as a reference for how your house wiring is. Most of these transformers, some may have the neutral bonded to the ground as well. Others may only have the secondary bonded. But here's the problem. I mean, the primary side can be bonded. That's not going to affect anything. For that matter, the transformer case can be bonded as well. You don't want this one, and you definitely do not want a ground wire going through. That is not how isolation transformers operate, because you've removed that safety factor of having a completely isolated output. And unfortunately, most of the transformers that you will buy are like this. In fact, to get UL certification, they probably have to be like that, because somewhere in the code they're going to say your outlet has to be grounded, and that is not what you want for a safety isolation transformer. The same goes for a Variac. You go and buy a Variac, which is just a voltage variable transformer. This is a schematic for a Variac. So you've got your hot and your neutral follows through to the neutral on your plug, your outlet, and then you've got this variable tap that you can turn up and down, which will affect the hot. So this is a hot line here, and this is a neutral. And they are always going to be hot, and they're always going to be neutral, and the neutral is always going to be connected to ground. Because remember, back at the utility pole and at your service entrance, that is the case. It is grounded. A true isolation transformer is this one here. You have a hot and a neutral going into your primary. Your secondary is connected directly to the outlet There is no connection. The ground wire, if there's a ground plug on here at all, would be not connected to anything, or at the very, very worst case scenario, it might be grounded to the case, just so that the transformer itself, the actual case, is grounded. But that is it. There will be no connection to a third plug. In fact, most of them will not even have a 3-prong plug. They only have a 2-prong plug on the output to prevent someone from plugging a 3-prong outlet into it. This is a true isolation transformer. This is what I use on my test bench. I have an isolation transformer, which has got a floating output. You see, there's no reference. There's nothing marked line or neutral here because there is no line or neutral. In effect, either one can be a line, and then if you were to reference it to a ground, you'll find that the output is floating. My Variac is connected to my isolation transformer. It has a floating output, and I can adjust the voltage on it. I have 2 cords sitting on my bench here. This one is plugged in directly, and this one is plugged into my isolation transformer. If I take my meter and I put the ground, so this is going to be line, ground, neutral. If I put my negative probe or black probe, because I want AC, and I measure here, we have 120 volts between line and ground. And between neutral and ground, we got 0.2, which is probably what the meter is going to measure anyway, just from picking up crap in the air. Now, if I go over to my isolated cord, we will see that there is not 120 volts on them. In fact, because they're floating, there is going to be some induction picked up, just because this is a high impedance meter. So when I measure, I'm seeing about 32 volts on one side. Okay, I guess that's the neutral side. And the other side, I'm seeing about 50 volts. If I measure between these two, I've got the full, whatever my Variac is set for, 122 volts. And I can adjust that up and down with my Variac. Okay, let's go back to the ground reference over here. This is the actual ground. And again, you'll see that it's floating. But it's not. It's really referenced to nothing. Right? 50 volts on one side, 31 volts on the other. Enter Mr. Resistor. What is this thing? I just grabbed a resistor at random. 330K resistor. So we're going to take one side of this resistor and we're going to just clip it to the ground over here. Now I can assure you, if I were to measure, and the other side of the resistor is going to go to the hot lead over here. Now I can assure you, if I were to measure between the ground here and line, I will have 120 volts, because that resistor is not going to, okay, be careful here because I got a line voltage here. I don't want to short anything out. If I measure here, keep my probes away from each other, we will see that I have 120 volts, right? Okay, now, keeping that one in ground, I've now put a 330K load across the meter. So this will dissipate the induction. And now if I go to my isolation transformer, you'll see that I got like 3 volts. And on the other side, I've got like 4 volts. And that's just because the 330K resistor is allowing a bit of a rise there, just still from induction if I went to a smaller value. But the thing is, I could put a jumper wire in here. We can do this. We can do this. Okay, you can see my ground wire is grounded there. Let's just ground this probe. Okay, now what do you think's going to happen when I stick this in here? Nothing. And nothing. Why? Because it's isolated. The transformer is isolating, and that is the whole point of an isolation transformer, is it'll isolate. Now, if I were to stick this into this one, of course you'd see major sparks, because I'm just going to put a full load from ground to the hot, and it'd blow the end of my probe off, and we'd have an electro boom moment, which we don't want to have an electro boom moment on this channel. But there you go. There's your isolation transformer. I don't know how I could explain it any simpler than that. To have a fully isolated isolation transformer, there can be no reference to ground or neutral. If you buy an isolation transformer and you put your meter in ohms mode, and attach it to the ground prong or the neutral prong, and go to the output, there should be an infinite reading between everything, because there is no connection. There's no connection between the hot and neutral and the output. So between here and here is infinite reading. Between there and either of these, it's infinite reading. Between ground and any of these, it will be infinite reading. There will be zero. It'll say OL if it measures anything when you're in ohms mode. If it measures anything other than OL, then it's not an isolation transformer. It has a ground reference somewhere along the line. And I can even show you that here. If I take my meter and I measure between ground and the it's measuring that there's a volt or two on here, but normally this would measure 0 ohms. But there's a little bit of rise between the ground and the neutral here. How many volts is it? I get like 0.2 volts, and that's of course affecting the meter. If I were to go flip the breaker off, well, probably not. It's some induction anyway, but in ohms mode, if I can turn off that low Z, there we go. That's volts. Where are we here? Yeah, here we go. See, there's no voltage, but it should read like 0 ohms. But this meter is very sensitive, so it's detecting that there's a little bit of voltage in ohms mode, and it's giving me a warning that there's voltage there. It's not much. Like it's like what did I say? It was like 0.2 volts, but yeah, 0.2 volts. And of course, on the other side, there's 121. If I go between neutral and hot, 121. Anyway, what I'm getting at is the ground and neutral are tied together. It's just that this meter is a little too sensitive. It detects that 0.2 volts and says, I'm not measuring it. Anyway, that's I just wanted to try to clarify things, because I get people that look at my other video and they think that I cut something out. They think they're missing something, and no, I didn't cut anything out. I thought I explained it well enough for people to understand, so this is just a refresher in how these things work. If you buy one off eBay, or you can go into a store and buy one, unless you specifically buy a serviceman's transformer. A serviceman's transformer will not have a 3-prong outlet on it. They will only have a 2-prong outlet, like mine, which I don't know if I've showed you this before. I don't know if I can show you because it's under my bench. Can we see it? I don't think we can even see it where it's mounted. It's mounted right at the back. But it's just a Hammond transformer. And if you look at it, well, it's not really anything to look at. It's got 3 sets of outputs on it, the one I've got, but they make them with single outputs as well. It's got three taps on it, basically. It looks like this. It's and it's got the power cord that goes in on one side, and the power cord has just a 2 outlet, like a lamp cord, and on the back here there's 3 outlets. $110, $120, I think this one's $125 or $130. It might be $125, or I'll call it $130. But anyway, it's got 3 outlets. I'm plugged into this one, and they just have two pins on them. I'm plugged into this one. This one goes off to my Variac. That goes off to my Variac, and it also has an outlet, but it's got a I had to cut the 3rd prong off to plug it into there, because it is completely isolated as well, because obviously a 3-prong outlet will not plug into that. But that's my setup. The reason I've done that is because the Variac would normally allow you to turn it between about 100 and 130 volts or so, but by giving it 130 on the input, I can go from 0 to about 150. I believe that's what I can get off of it. We can test it. We'll just, I don't think there's anything that's plugged in here now that'll blow up. If I crank it up, so if I grab my probably has stuff plugged in that will blow up, but I won't leave it up there very long. If I put my meter on, where are we here? Let's get AC volts. Plug that in properly. All right, 120 volts. So I can go down to 0. And I can crank this up. All the way up. Keep going, keep going, keep going. 151 volts. That's there so I can voltage stress things, right? If I've got a power supply that's kicking out and the voltage rises a little bit, because the voltage normally does fluctuate slightly throughout the day. Sometimes you'd have TVs that would go into X-ray protection if when the voltage went up a bit, if there was a regulator problem. So that just gives me flexibility. Instead of being able to go up to 130, I can go up to 150. We'd never see that in the real world, but it just gives me that flexibility that I can go up there. And into my Variac, I actually have a little power bar that has a few things plugged into it. So I hope I didn't stress things that are plugged in, like my TV, too much. I think the TV can handle that. But anyway, that's my setup that I've got here. That's an isolation transformer. If you're getting one, you got to look for one like this. If you get one like this, open it up and cut any reference to ground. Cut the ground prong off here, cut the ground off on here, and cut the ground between the neutral and the secondary. And I've done one. I did a mod for a guy who bought one that was this configuration, and he shipped it to me to have the grounding removed. Another thing to point out, when you're plugging in test equipment, you can plug your test equipment into this output as well. Or not this one, but this output here as well, with no ground. Don't plug your test equipment into an outlet with a ground, because adding a ground, like if you've got your scope hooked up, for example. So you got your product plugged in, and you've got your oscilloscope connected to the chassis, and your scope is grounded. I guess it's this side, I'll show you here. So if you've got it plugged into your oscilloscope, right, and your scope has got, even if it doesn't have a third prong on here, but if your scope is plugged into an outlet that's got a grounded outlet, so your scope is grounded, right, and you've got your chassis is connected to the ground on your probe, right, you've got your little ground here, you've now restored, through that scope, having that scope grounded, you've now basically connected a ground up to here, and you've now removed the isolation. So if you're hooking up an oscilloscope and stuff and you're testing it for leakage or whatever, or you want to be safe, remove the ground pin off the scope cord, or plug your scope into, better still, plug your scope into here. Power it up from the isolated output, because that way you've removed the ground reference. But again, be safe, as they say. It's a safety must if you're dealing with any line connected equipment. If you're working on anything that you could get a shock. Now you could still get a shock through an isolation transformer. The idea behind an isolation transformer is it prevents you from becoming the path to ground. So with either of these floating, and there's no connection between the earth ground and the equipment, if you are touching something that's ground, if you are the ground, you are not going to complete a circuit from line. You will basically do what I did with that resistor. You will pull whatever side you're connected to, you will pull that towards ground through you, but no current will flow because there's no direct reference back here. Right? It's not connected back to the utility pole. It's connected only to your output of your transformer. Now, if you were to touch either side, if you're touching ground and you touch either side, you will not get a shock. Now, if you were to touch both of these at the same time, well, yeah, you're going to get a shock, because you don't need a reference to ground. You've just provided the complete circuit to get from one side of the transformer to the other. But from either side to ground, you will not get a shock. You won't even feel it. And it won't trip a GFI either, because there's no current flowing through your body. I don't know. I thought I made it clear before, but I guess some people need a little refresher. I think that's as simple as I can explain it. You want an isolation transformer or an isolation transformer going into a Variac, but it must be one that's fully isolated. And you can determine that with your meter. Your meter will tell you immediately. If you get any readings back from the either from the input side to the output side or the output side to ground, then you have a isolating transformer. Does that make sense? Isolating transformer and isolation transformer. I guess that's what we should call them. This is an isolating transformer, as it isolates the hot side from the utility hot, but it does not isolate the ground. So that's an isolating transformer, and this is an isolation transformer because it totally isolates the output from the input with no reference to ground. Thanks for watching.